Here are the top 10 most important things to know about linear relationships. Must know number 1. What do linear relationships look like? Let me show you how you could recognize a linear relationship from the 3 ways that any relationship can be represented: with an equation, with a table, and with a graph. An example of an equation of a linear relationship would be y equals 2x plus 1. Any linear relationship is just a variation of this one, where the dependent variable y is equal to a constant multiple of the independent variable x, and that constant being multiplied by x we often call the slope coefficient, plus some constant added to the x. Also notice that the exponent on the x is a 1, which makes this a degree 1 polynomial function. If I were to make a table of values for this equation, I could choose any values I want for x. I'm going to make sure I choose values that are evenly spaced, so I'll choose from -2 to 2 going up by 1s, and then I'll calculate their corresponding values of y by taking each of those x values, subbing them into my equation that tells me the relationship between x and y. So for example, if x is -2, y would be 2 times -2 plus 1, which is -3. I could do that for each of the x values I chose, and I would get each of these corresponding values of y. From this table, I should be able to tell that I have a linear relationship, and I can do that by analyzing the difference in consecutive y values. So if I look at the first pair of y values and find the difference by doing the bottom one minus the top one, -1 minus -3, that's 2. The difference in each pair of consecutive y values, notice it's 2 each time. So that tells me as the x values are increasing by 1, the y values are increasing by 2. Because they're increasing by a constant amount, I know it's a linear relationship. All linear relationships have constant first differences. And if I were to graph each of the points that I have in my table of values here, notice that if I were to connect these points, they form a straight line. Linear relationships are called linear relationships because they form straight lines when graphed. So now you know how you can easily recognize a linear relationship from either its equation, its table of values, or its graph. Must know number 2, slope. You have to know how to be able to find the slope of a line, or another word for slope is the rate of change. We're going to look at the graph and table of values for the linear relationship y equals -2/3 x plus 1. Let's start by finding the rate of change or slope of this relationship from its graph. So if I look at its graph, when I say I want to find its rate of change, I really mean I want to find the slope of the line. And I use the letter m to represent slope. And to calculate the slope, we have to figure out what is the quotient of the change in the y values divided by the change in the x values. So as x is changing, what's happening to y? To calculate that, we have to pick 2 points on our graph. Any 2 points will do, but make sure you pick points that you for sure know the coordinates of. And then what we want to analyze is, how are the y values changing between those 2 points, which means what is the vertical distance between those 2 points? And we actually have a word for that when we're talking about the graph of a line. We call that the rise, and we divide that by what is the change in x between the points. So what is the horizontal distance between the points? And we have a word for that. It's called run. So to get from this point to this point, I have to go down 2. So we would say that the rise is -2, and then I would have to go to the right 3 units. So we say that the run is 3. Something that I should note for you is that when counting the rise, if you are going up, we consider the rise to be positive, and if we're going down, we consider the rise to be negative. For the run, if we go to the right, the run is positive, but if we go to the left, the run is negative. Now to get this rate of change or slope of -2/3, we wouldn't have had to pick these 2 points. Linear relationships have a constant rate of change. They have a constant slope, which means we could have picked any 2 points and got that same answer. Let me demonstrate that to you. What if I picked the same first point, so at -3, 3, but my second point that I picked was way over here at 6, -3. The slope, m, would be rise over run, and the rise, I said we would have to go up 6 units, which means the rise is +6, and then we would have to go to the left 9 units, which means the run is -9. 6 over -9 could reduce to -2 over 3. Notice the same value we got when we chose the first 2 points. Now that you know how to find the slope of a line from a graph, let me erase the second slope calculation that we did, and let's focus on calculating slope from a table of values. If I were to make a table of values for this linear relationship, I would pick some x values, and then calculate the y values, and then to calculate the slope, I need to figure out what is the change in the y values divided by the change in the x values. Since we don't have a graph to count the rise and the run, we have to pick 2 points from our table to algebraically calculate what the rise and run would be. I'll pick -3, 3 to be my first point. I'll call that x1, y1, and then I'll pick 3, -1 to be my second point. I'll call that x2 and y2. Now to find the change in y, we could follow the formula y2 minus y1 over x2 minus x1. That just finds the difference in y and the difference in x and then divides them. If I follow that formula, I would have -1 minus 3 divided by 3 minus -3. That's -4 over 6, which reduces to that same value we've been getting each time, -2/3. Now you know how to find the slope of a line from a graph or from a table of values. Must know number 3, slope-intercept form, y equals mx plus b. This is the most common format that you'll see linear relationships represented in. In this format, m stands for the slope of the line, or its rate of change, and that's calculated by doing change in y over change in x, which we could do in 2 different ways. If we have 2 points, we can find the difference in the 2 y values and divide it by the difference in the 2 x values, or graphically, we can just count the rise and the run and find their quotient. The b value in y equals mx plus b is the y-intercept of the line. So let's look at, if we have the graph of a line, how could we come up with its equation in the form y equals mx plus b? And also, if I give you the equation of a line, how could we use that equation to sketch the graph of the relationship? Let's start by looking at the graph of this line. If I want to write its equation in the format y equals mx plus b, I'm going to need to know m, its slope, and b, its y-intercept. Let's start by finding m, the slope of the line, which I know I can calculate using the formula rise divided by run. To count the rise and the run, I have to pick any 2 points that I know are on the line, and then to get between the 2 points, count the rise, which is the vertical distance between the 2 points. So I would have to go up 2, which means the rise is 2, and then the horizontal distance between the 2 points, we call that the run, and I see I would have to run 4 units to the right, which means the run is 4. And 2 over 4, of course, reduces to a half. The b value is just the y-intercept. That's just where does it cross the y-axis, and it crosses at 2. So my b value is 2. So when I write my linear relationship in the form y equals mx plus b, it would be y equals 1 over 2x plus 2. Let's now look at what if I gave you the equation of a linear relationship, and then I asked you to sketch the graph of this relationship. We don't have to make a table of values. We can just use our understanding of the properties of the y equals mx plus b formula. The constant that's being added to x is the y-intercept. So in this question, the y-intercept is 4. So I can plot a point on the y-axis at 4. And the slope is the constant being multiplied by x. So our slope, which we call m, is -2. It's often useful to think of the slope as a fraction. So any whole number is over 1. Slope is rise over run. So starting at this y-intercept, I need to rise -2, which means go down 2, and then run 1, which means go right 1, and then plot a point. And then I can just continue that pattern of going down to right 1 to continue plotting more points. To get points on the other side of the y-intercept, we can do the opposite. This negative sign can go down to the bottom of the fraction and it doesn't change the value of the fraction. So that slope of -2 over +1 is equivalent to a slope of 2 over -1. Both of those have a value of -2, so they're equivalent. But the second version would tell me to rise +2, which means go up 2, and run -1, which means go left 1. So if I go up 2 and left 1, notice I get another point that is on this linear relationship. So there you go. Now you know how the slope-intercept form equation of a linear relationship, y equals mx plus b, is connected to its graph. Must know number 4. Standard form. Linear relationships can be represented in another format that looks like this. Ax plus by plus c equals 0, where a, b, and c are any integers. An example of a standard form linear relationship would be the equation 3x plus 6y minus 12 equals 0. Now, it should be noted that we could reduce this equation, dividing it by 3 to get x plus 2y minus 4 equals 0, but we'll work with this version. The usefulness of writing a linear relationship in this format is that it's easy to calculate both the x and y-intercepts of the linear relationship. If I want to know the x-intercept, graphically that means where does it cross the x-axis? Well, wherever it crosses the x-axis, I know its y-coordinate would be 0. So to calculate the x-intercept, we just have to set y equal to 0 and solve for x. If I do that in the standard form equation that we have the example of, I'd have 3x plus 6 times 0 minus 12 equals 0. I would have 3x equals 12. Divide the 3, I get x equals 4. So the x-intercept is at the point 4, 0. So on my graph, I could plot the point 4, 0. If I wanted to calculate the y-intercept, graphically that means where does it cross the y-axis? Well, wherever it crosses the y-axis, at whatever point it does, I know its x-coordinate is 0. So to calculate the y-intercept, we just set x equal to 0 and then solve for y. If I do that, I would have 3 times 0 plus 6y minus 12 equals 0. That leaves me with 6y equals 12, which means y is equal to 2. So the y-intercept is at 0, 2. Now that we have 2 points that are on this linear relationship, we can accurately graph it. There's only one line that would cross through these 2 points, and that line would look like this. Now, another important thing for you to know before I move on from this section would be for you to know how to convert between the slope-intercept form of an equation and its standard form equation. So what if I give you the equation in the format y equals mx plus b? So for example, y equals negative 2/3 x plus 5. To convert that into standard form, we would start by getting rid of any fractions. And I could do that by looking at the denominator of the fraction and multiplying the whole equation, which means all terms on both sides, by that denominator, which gives me 3y equals negative 2x plus 15. And now for it to be in proper standard form, notice I need to have all the terms on one side of the equation. So if I bring everything to the left, I would have 2x plus 3y minus 15 equals 0. What if we start with the standard form equation and we want the slope-intercept form of the equation? So we might as well work with this standard form equation that we did over there on the left. To get that into slope y-intercept form, I just have to rearrange it to isolate this y. So I'll start by isolating the 6y by moving the 3x and the negative 12 to the other side, making it negative 3x plus 12. Now I'll divide everything by 6 to isolate y, which would give me y equals negative 3 over 6x plus 12 over 6. And that simplifies to y equals negative a half x plus 2. And notice if I look at the graph of that linear relationship, this slope-intercept form tells me its y-intercept at 2 and its slope of negative 1 over 2, which means down 1, right 2, down 1, right 2. There you go. You now understand the properties of the standard form equation, what it's useful for, and how to convert between the formats of a linear relationship. Must know number 5, the point-slope form of a linear relationship. This is the third and final format you might see a linear relationship in, which is y minus b equals m times x minus a. In this version of the equation, m still represents the slope, but what's unique about this formula is that a and b, the values being subtracted from x and y, represent a point that is on the line. Let's start by looking at if I give you the graph of a linear relationship, how can we generate the equation in point-slope form? I know I'm going to need to know the slope, I'll call it m, which I can calculate just by picking any 2 points on this line and then counting the rise and the run between those 2 points. To get from my first point to my second point, I would have to go down 1, so my rise is negative 1, and then I would have to run 4, so my run is 4. So in my point-slope form equation, it's going to look like y minus b equals negative a quarter times x minus a. All I would have to do now is sub in any point that's on my line for a and for b. So how about this point right there? The point 4, 2. that can be my a and my b value. So the point slope form equation is y minus 2 equals negative a quarter x minus 4. That would be the final equation in point slope form. Let me take 1 second and actually explain to you why that makes sense. We know linear relationships have a constant slope. They have a constant rate of change. So it wouldn't matter which 2 points I chose on my line. When I did my slope calculation, I would always get negative a quarter. So let's say I chose some random point here that has an x and a y value. If I were to find the slope between that xy point and this point right here, 4, 2, to calculate the slope, I would find the change in the y coordinates. So I would do y minus 2, divide that by the change in the x coordinates. So I would do x minus 4. And because all lines have a constant slope, I know that that calculation, no matter what xy point I plugged into it, I would get the answer of negative a quarter. So I can set that slope calculation equal to negative a quarter. And now I could just multiply this x minus 4 to the other side of the equation, and I would have y minus 2 equals negative a quarter times x minus 4, which is the point slope form of the equation we got over here. Let's now look at what if I give you the point slope form of the equation and you need to graph the relationship. Well, let me give you a point slope form equation. How about y plus 3 equals 2 times x minus 1? I would start by plotting a point that I know is on the graph of this relationship. Remember, the values that we're subtracting from x and y, so the a and b values, are a point that is on the linear relationship. So from x, I'm subtracting 1, and from the y, I must be subtracting a negative 3 to make it look like plus 3. So I know that a point that is on this line would be the point 1, negative 3. I'll plot that point, and then I need to use my slope to plot more points. And what's the slope? The slope is the m value, which I see 2 in place of m. If I think of 2 as a fraction, that's 2 over 1. So I have to rise 2, which means up 2, and run 1, which means right 1. So from that point, I'll go up 2, right 1, and plot another point, and then continue that pattern to fill the grid. If I connect all these points, I see my straight line relationship between x and y. There you have it. Hopefully now you understand the point slope form of the equation as well. Must know number 6. Find the equation of a line given 2 points that are on the line. Let's do an example. Let's find the equation of the line that goes through point A, which is 2, negative 3, and point B, which is the point negative 4, 1. Let's start by writing the equation in slope-intercept form. That's y equals mx+b form. Let me start by plotting the 2 points we have. If I want the equation in slope-intercept form, I need to solve for m and b. M represents the slope, which when we have 2 points, we can follow the formula that tells us we can do change in y over change in x by finding the difference in the 2 y coordinates, y2 minus y1, divided by the difference in the 2 x coordinates. If I pick point A to be my first point, that's my x1, y1, and if point B is my second point, that's my x2, y2. If I sub those values into my slope formula, I get 1 minus negative 3 divided by negative 4 minus 2. That's 4 over negative 6, which would reduce to negative 2/3. If I want to solve for the b value of this linear relationship, well, we know m, and we know 2 xy points. We just have to pick one of them. We could sub those in for m, x, and y, and then solve for b. So I'll write y equals mx plus b. I'll pick point A to be my xy point. So the y value is negative 3. My m value is negative 2/3. My x value is 2. And then my only unknown for this relationship is b. So I have to solve for b. I have negative 3 equals negative 4/3 plus b. To isolate b, we'll move the 4/3 to the other side. I've got a negative 3 over 1 plus 4/3 equals b. I'll rewrite that negative 3 over 1. I want a common denominator, so I would multiply top and bottom of it by 3, making it negative 9 over 3. So I get a b value of negative 5/3, which means my final equation for this relationship in slope-intercept form is y equals negative 2/3 x minus 5/3. Let's connect the points on this graph and see if that matches the equation we found. The y-intercept on the graph looks like it's at about negative 1.67, good. And the slope between the points is supposed to be down to right 3. That's my rise and my run. So if I go down to right 3, yep, I get a point. Down to right 3, another point. Down to right 3, another point. Don't forget, we could also write the other two versions of the equation. We could write the standard form or the point slope version. I'll show you those quickly. Standard form, I would multiply this whole equation by 3 to get rid of the fractions, giving me 3y equals negative 2x minus 5. I would get everything to one side, making it 2x plus 3y plus 5 equals 0. That would be the standard form equation. The point slope equation, I would use 2, negative 3 as my a and my b values, which would give me y plus 3 equals my slope, negative 2/3, times x minus 2. So when asked to find the equation of a line connecting 2 points, we could have it in any 3 of these formats. All 3 of those formats are equivalent to each other and all represent that straight line relationship between those 2 points. Must know number 7, parallel and perpendicular lines. Parallel lines have the same slope. So if I were to draw 2 parallel lines, they've got the same slopes, which mean they would never cross each other. Let's do an example that involves parallel lines. Let's find the equation of a line parallel to y equals 3x minus 5 and goes through the point 7, 1. Since I know it's parallel to y equals 3x minus 5, I know it has the same slope. And since y equals 3x minus 5 is in slope-intercept form, I know the coefficient of the x, 3, is the slope. So my parallel slope is 3. And then I can use the point 7, 1 as an xy value that is on my line. With that information, I could write the equation in the format y equals mx plus b fairly easily. Sub in 1 for y, sub in 3 for m, 7 for x, and then solve for b. If I solve this for b, I figure out b is negative 20, which means my equation is y equals 3x minus 20. And then I could quickly sketch the graphs of these two lines to show you that they're parallel to each other. Y equals 3x minus 5 has a y-intercept of negative 5 and a slope of 3, which means up 3, right 1. Y equals 3x minus 20 has a y-intercept of negative 20, which I'm not going to be able to fit on the screen here. But I do know it goes through the point 7, 1. And from there, I have a slope of 3 over 1 as well. So I could go up 3, right 1. Or I could think of it as negative 3 over negative 1, which means down 3, left 1. Notice that those two lines are parallel, they would never meet. How about perpendicular lines? Two lines that are perpendicular cross at a 90-degree angle. And a property of their slopes is that they are negative reciprocals of each other. And slopes that are negative reciprocals have a product of negative 1. So two perpendicular lines, wherever they cross, there's going to be a 90-degree angle. I'll explain this word negative reciprocal with an example. Let's find the equation of a line perpendicular to y equals 1/4 x plus 2 and goes through the point negative 1, 5. Now, since we did the last equation in slope-intercept form, let's do this one in point-slope form. Remember point-slope form, y minus b equals m times x minus a. If I want m, the slope, well, I know it's perpendicular to a line that has a slope of 1 over 4. Perpendicular slopes are negative reciprocals. Negative means multiply it by negative 1, so change its sign. And reciprocal means do 1 over the value, which means flip the fraction. So 1 over 4, I have to flip the fraction to make it 4 over 1. And I have to multiply it by negative 1, so it becomes negative 4 over 1, which is just negative 4. So my perpendicular slope would be negative 4. The point that the line goes through is negative 1, 5, so I can make that my a and my b values of my point slope form. So the point slope form equation would be y minus 5 equals negative 4, x minus negative 1, which I would write as x plus 1. And let me graph these two lines so you can see what they look like. Y equals 1/4 x plus 2. It has a y-intercept of 2 and a slope of up 1, right 4. And this equation goes through the point -1, 5, and has a slope of -4, which means down 4, right 1. Notice those lines are perpendicular to each other. They meet at a 90-degree angle. Must know number 8, horizontal and vertical lines. Let's start with horizontal lines. Horizontal lines always are of the format y equals b, where b is the y-intercept. So for example, the line y equals 3 would be the horizontal line through a y-intercept of 3. So if I plot the y-intercept of 3 and draw a horizontal line through that point, I have the line y equals 3. Why is this defined as y equals 3? Well, if we think about all the points that make up this line, what is the y-coordinate of all of those points? The y-coordinate of all of those points is 3. That's why we define that line as y equals 3. How about a vertical line? Well, if for a horizontal line, the y-coordinates don't change, they're constant. For a vertical line, the x-coordinates don't change, so they're defined as x equals a, where a is the x-intercept. So an example of this would be x equals -2. If I plot an x-intercept of -2 and draw a line that goes through that x-intercept, that line has the equation x equals -2. And why is it x equals -2? Well, if we think about all the points that make up this line, the x-coordinates of all of those points is -2. The other thing I should show you is what is the slope of horizontal and vertical lines. Let's start by looking at the horizontal line. In fact, the slope of all horizontal lines is 0. Why is it 0? Well, if I were to pick 2 points on this horizontal line, let me label their coordinates. Remember that when calculating slope, we're finding rise over run or change in y over change in x between those 2 points. Between those 2 points, the rise is 0, right? The change in the y values is 0 minus 0, which is 0, and the change in the x values is 5 minus 2. So my slope is 0 over 3, and 0 divided by any number is 0. For any horizontal line, your rise is going to be 0, which is going to make the whole value of the slope be 0. What about vertical lines? The slope of any vertical line is actually undefined. I'll show you that by labeling a couple points on this line. And then to find the slope, I'll do rise over run or change in y over change in x. The change in the y values is 4 minus 2. But the change in the x values, there is no change. -2 minus -2 is 0. So my slope is 2 over 0. And anything divided by 0, we say is undefined. For any vertical line, the change in x, or the run, is going to be 0. So the slope of all vertical lines is undefined. Must know number 9, point of intersection by graphing. If I give you the equation of 2 lines, you need to be able to find where the 2 lines intersect, which algebraically means which xy point satisfies both equations. Since both of these lines are in slope y-intercept form, I know that m represents the slope, so the slopes of these lines are 1/2 and 4, and the b values are the constant terms, 2 and -5. Those represent the y-intercepts. I can graph line 1 by starting plotting the y-intercept at 2, and then use the slope of 1/2. Remember, slope is rise over run. I can rise 1, run 2, and plot a point. And then I can follow that pattern to fill the grid, and I have the graph of line 1. Now I also have to graph line 2 and see where they cross. And now to graph line 2, let me do this in a different color. I can graph line 2 by plotting its y-intercept at -5, and then using the slope of 4 over 1, which tells me to rise 4, so up 4, and run 1, which means to the right 1. So if I go up 4 and right 1, I can plot another point on this line, and then continue that pattern, and I'll see it actually intersects the other line right there at the point 2, 3. So this right here is my point of intersection. Algebraically, if I were to take this point 2, 3, sub in for x and y into line 1, and x and y into line 2, it would satisfy both equations. And that's the only point that makes left side equal right side for both of those linear relationships. Must know number 10, finding the point of intersection algebraically. Let me once again give you 2 linear equations. If you wanted to find the point of intersection of those linear relationships, you don't have to graph it. There's actually two methods you can use to find the point of intersection algebraically. The methods are called substitution and elimination. For the method of substitution, I like to start by writing the linear relationships beside each other. You then have to isolate one variable in either of the two equations. This y would be the easiest to isolate since its coefficient is 1. Isolating it would be y equals negative 4x plus 7. You then take what you know y is equal to from the second equation and sub it in for the y in the first equation. You're essentially making their y coordinates be equal. That would give me 3x plus 5 times y, which I know is equal to negative 4x plus 7, equal to 1. So I've made their y coordinates be equal, and now I'm going to solve for what value of x allows that to be true. I can distribute the 5 to both terms. 3x minus 20x plus 35 equals 1. I have negative 17x equals negative 34. Divide the negative 17, I figure out x equals 2. I can now take that answer I got for x, sub it into this equation for x, and then solve for y. If I do that, I'd have y equals negative 4 times 2 plus 7. Negative 8 plus 7 is negative 1. So the point 2, negative 1 is the point of intersection of those two linear relationships. Or algebraically speaking, these are the x and y values that satisfy both of those equations. The other method that you could use for finding that same point of intersection is the method of elimination. To start elimination, you start by writing the equations on top of each other. And now you want to make the coefficients of either the x's or the y's have the same absolute value. I could make the coefficients of the y's be the same if I multiplied this bottom equation by 5. The top equation I can leave the same. And now what I do with these two equations is I need to subtract their like terms to generate a new equation that will allow me to solve for x with the y variable being eliminated. If I subtract the like terms, 3x minus 20x is negative 17x, 5y minus 5y is 0y, the y's are eliminated, and 1 minus 35 is negative 34. If I solve this equation for x, I get x is 2, and then we could take this answer for x and sub it back into either original equation for x and solve for y. If I sub it back into the first equation, I'd have 3 times 2 plus 5y equals 1. 5y equals negative 5, which means y is negative 1. So my point of intersection, again, I would get as 2, negative 1. Hopefully this video helped you understand linear relationships better. Let me know what you want a top 10 of next. Jensen